I just uploaded my last devlog, and I have midterms this week. I should really catch up on my classes. But like the bottle of Smirnoff Berry Blast sitting in my freezer that's been calling my name for the past 6 months, I just can't help myself. So, here's to the beginning of probably the longest project of my life, a little multiplayer game, which I can enjoy with my friends and family. My idea is to create a simple client-side PvP game, like Worms WMD, or even Stickfight, where I have a simulated solar system, kind of like Outer Wilds, and every player gets their little planet, which has its own little orbit that is different from the other ones. I am very excited about this project because I get to utilize the years of physics I willingly took for some reason. Okay, so let's create a new Unity project, and then set up the networking asset I will be using for the game, which I decided on using Mirror. It's the best for what I'm hoping to achieve and relatively easier to set up and learn than the other options from what I gathered. Next, I got the player spawning to work with the networking system, which I can check on different instances of Unity. Now let's make the solar system. First, let's add a little star, which for now is just a stationary yellow ball. And then let's add a little planet that can orbit around. But it's actually pretty difficult to get the orbit just right by adding a velocity and just praying it orbits around. So let's create a simple orbit visualizer. Now, if I'm being real, I don't really know how to implement this. Actually, I have no idea how to implement this. So I guess let's do some research. Okay, so I found this pretty well-known method for prediction calculations. It's called Euler's method, made by the GOAT himself. Leonard Euler? Or is it Leonard Euler? I'm gonna go with Leonard Euler. It's not the most efficient, but it should work for what I'm trying to implement here. Let's say you have an object thrown up in the air, 10 meters up from a relative floor, and this is the graph of its height over time. If we want to predict its trajectory, all we need is the initial position and its velocity at every point, which is the derivative or the slope of the function. Now you may be thinking, how do you find the velocity at every point? Well, we know the acceleration due to gravity, which can be used to figure out what the velocity is. But for this example, I am using the actual velocity at every calculated point. Euler's method tells us that the next estimated point at a chosen difference in time, delta t, will be the current point plus the velocity times delta t. Plugging in the numbers, we get the next point and we can draw a line to it. Doing this for every next point, we get an estimate of the trajectory of the object. But this does not look very accurate. Well, if we choose a smaller difference in time, we actually get a much better estimate. The only downside is you actually have to do 10 times more calculations, at least for this chosen delta t. As you can see, my implementation works perfectly, and I actually finished a lot of the systems I wanted to finish for this project. This video took a really long time because, I wanted to see what I could finish before uploading the video. And a week ago, I finished the networking system, and and it got me thinking about what I should do next with this project. And then I was just like, well, there's still a lot to do, and if I wanted to do multiplayer testing, I'd have to either use Steam's networking or some other system, which would take a really long time. So, I'm like, well, I kind of want to make something that I know would take, less than half a year. So for now, I'm going to take a break from this project, as much as it saddens me. But I think, it'd be more fun to make something simpler, that I can get done quick, and that I can actually ship out quicker. If anyone's curious about any of the systems I implemented here and would like a further deep dive into them, I'm happy to do that. But otherwise, thank you for watching and subscribe to see what I make next.